All right. Okay, so let's talk about this keyword first. And then I want to talk about a couple other things. So tell me, what is this keyword? And my hope is that you found it challenging trying to describe this keyword. Because it's one of those things that is, it's difficult to say what this is without saying the word this.
Like if you initialize some variables, I don't know, in like main or another method, you don't have to reinitialize them somewhere else. You can just write this, and the value that you put in for that variable gets called down to where you're working.
Okay. So what you're kind of describing is more of a functional use of this keyword. So not necessarily off topic, but doesn't really tell me a whole lot about what this keyword is, what its purpose is. Go ahead.
How an object can refer to its own members.
Okay. We're going to say that's about 72% there. So the definition I usually throw out there, and keep in mind this has evolved over like 18 years of teaching, so this is a better definition than there was a while ago. It's how an object refers to itself from within itself. So this keyword is how an object refers to itself from within itself. And if we're going to connect this to kind of is this open for editing? Oh no, it's view only. Somebody else just opened it, that's fine. Because I've had that issue before with an upper division class who had me for like 3.5 years and took some liberties. Live, during class, on recording, changing my slides to things they should not have been changed to. Boys are so immature.
It's a little bit fun.
Huh?
It's a little bit fun with the slide.
We did get a kick out of it, yeah, but it's always awkward though, because you got 2 or 3 serious students in the class that most people could find some humor in that, but then when it crosses a line, and then I'm like the scapegoat, right? I had nothing to do with this. I mean, I might have found it funny, but officially, it's like, all right. So it's how an object refers to itself from within itself, and if we're connecting this to kind of a real life example, which I like doing, so that we don't get too ingrained into this idea that programming is so different. When we talk about ourselves, we say me or I. Does that make sense? Like, I am going to go to the grocery store, that type of thing. That is equivalent to what this keyword is. So if we're dealing with an object, this is how an object refers to itself, just as I or me is how a human object, a person, refers to themselves. Does that make sense? And kind of the reason for this, the reason we need this, with human beings, we're flexible, right? So, we can fill in a bunch of the blanks. It's always weird when somebody talks about themselves in the third person, right? It's like, well, Mike's going to go to the cafeteria. It's weird, right? But you all know what I meant. And then you have to go through that filter, like, well, was he joking, or is that is that a thing? Is how some people, if that's their thing, they talk. Hey, you have a supervisor supervisor of a supervisor who does that. You can connect those dots. But I bet you know exactly what I'm talking about. All right, so in any case, and it's not your dad. It would be his supervisor. All right, so yeah, so we need a way of referring to ourselves programmatically, because when we're dealing with programming, we have rules, right? We've talked about scoping rules. That's kind of the one we're going to be discussing here over the next few minutes, where certain variables, and this is kind of what you were alluding to, we don't have access to from certain places. We don't have that variable name, and we kind of need a way of talking about ourselves without externally naming ourselves. In real life, as a human being, when I say Mike is going to the cafeteria, you think it's weird, but you know that I'm talking about myself because human beings can connect those dots, right? In computer programming, the variable Mike, which is the variable that refers to me, would be out of scope inside of my head. We wouldn't have access to that. That's an outward variable that you guys have access to, but it's not available to me inside of my head from a programming sense. Kind of make some sense? All right, so as an example, and actually why don't we, rather than come up with a hypothetical, let's just go ahead and start creating a little object here so we can connect the dots directly. Let's see. Are we still debugging? What are we doing? All right, let's see. I think is that the view? Yeah. So up here is where you can flip back and forth between the debugger view and the Java view, and every couple of versions they move these buttons around a little bit, but roughly all in the same place. All right, and this is which is this us here? The guy. All right, so we kind of started this a while ago. So this is when I first I think it was right at the end of a class, we introduced the idea of an object. All right, and this was related back to a previous assignment we were doing. So let's kind of flesh this out a little bit. So we want to have an object that refers to a player. We want to have an object that refers to a player. And when we build a player, we have this thing called a constructor. Now, based on the reading, tell me, what are constructors? So that could have been a quiz thing too. So what's a constructor? Go ahead.
Doesn't have a return type. It's not void. It's never known. Class member method can be used to initialize fields.
Okay. So let's flesh that out a little bit. I think most of that is accurate stuff, but let's give some meaning to what those sentences say, right? So constructor, so maybe we say it's like a method, but no return type. Something like that, right? I'm going to come back to that here in a few minutes, and I'm going to ask you why it doesn't have a return type. Okay, we're going to kind of see that through some evidence. So looks a lot like a method, but there's no return type. Still has a name, still has a potential parameter list. Now, is there anything special about the name of a constructor in Java? Can we name constructors anything we want? Has to be named the same thing as the class name, right? So name must be identical to the name of the class. This is case sensitive. And that idea of case sensitivity is pretty much a global expectation in programming. Every now and then you'll run into a language that lets you be kind of loose about capitalization and stuff like that, but we're going to call it 99% of the time. If you have a variable that has a lowercase m in it, when you use it, use a lowercase m because it's going to scream at you. Okay? Case sensitivity is important. All right, so the name must be identical to the name of the class. So that's a kind of a rule of constructors. All right, and then you kind of mentioned something along the lines of it used to initialize something, right? So when we think about a constructor, it is the method like dude that initially sets up an object when it is first created. This will be things like initializing default values, doing any logic that is required before the object is usable, etc. All right. So if we're connecting this to kind of real life, I want a new house. All right. So we want. Well, I know I like my house. My wife wants a new house with a sunroom. Do you know sunrooms are expensive? You might as well buy a new house to get a sunroom. Yeah. So she wants one of those. But anyway, so we want a new house. Now, to get the perfect house, you can go and search on the market, but that's not our example here. We're going to build a house, all right? So we have this idea in our head of what this house looks like. But then we need to actually have somebody build that house for us, have somebody construct the house for us, right? Now, in real life, what is that? That's probably a contractor or something like that, right? And what do I need to do? I need to kind of give them. He might come up with the blueprints or something, but I have to give him all my ideas for what I want. But most importantly, I give him money, right? So I give the contractor money and he magically does what's required to initialize a house. He pours the foundation, builds all the walls, all that stuff, runs the electrical. He does all the house building stuff. He constructs the house object with the material that I give him, which in real life would just be money. Or money plus a blueprint or something like that, right? Okay. Constructors and objects work the same way. Okay. This is the dude who's in charge of building our object for us. And he may need some information, some parameters, some inputs in order to pull that task off. Now, not all objects will require that, but some will. So that constructor is the guy that we use right at the beginning when we're first bringing that object into existence. When it goes from a blueprint, so when we have a class for an object, that's a blueprint. If we come back here, this whole thing here would be similar to our, the blueprint for our house. Okay, looks great on paper, but it's not a house yet. This is an idea. This is instructions for building a house, right? And not until we actually tell a contractor, here's some money, go and build me one of these, does it actually come into existence. That's the constructor. Make sense? Go ahead.
So the constructor actually builds the object.
Mm-hmm.
So the class comes before the object.
The class is our blueprint. So if we're thinking about this with our house example, so this class here is our piece of paper that shows us the schematics of the house, what it will take to build that guy. But it's not physically an object. It's a description of the features of the object. Then the constructor takes that blueprint. In this case, he's kind of part of the blueprint, but he takes that blueprint and creates the physical object. All right, in our computer's memory, so it's still, we'll say it's physical. You don't have to get too weird about it, I guess. But so we have the physical object at that point. That was the constructor's doing, with the new keyword, and we'll kind of connect those dots here in a few minutes. But that's the job of the constructor. Okay. So as an example here, I might go ahead and we're going to go ahead and create the player constructor, and as Van pointed out, it's got to match the name of our class, case sensitive. So this guy's name is going to be player, okay? And as he pointed out, we are not going to have a return type before this guy, okay? We could have things like public in front of it, but we haven't talked about that yet, so let's pretend like that doesn't exist. So we're going to name it player, okay? And we're going to say, in order to build a player, we need them to pass in a jersey number and a rating so that we can initialize those fields. These guys up here are called fields. So fields are variables associated with an instance of an object. Okay? And we're going to talk a lot more about the idea of instance stuff versus class stuff. All right, so these are our fields. So to build a player, we might need some initial information to initialize these couple of variables. Because what differentiates, in our little world here, players from each other? Well, their jersey number and their rating is what differentiates them from each other. We're not even giving these dudes names. Right? So what makes them different from each other is their jersey number and their rating. So we're going to go ahead and we're going to take in an int jersey number and an int rating. Like that. 2 parameters. Okay? Now what we're going to do is we're going to say jersey number is equal to, and if you're writing this in ink, don't write this down yet because I'm about to introduce errors, is equal to jersey number, and rating is equal to rating. Okay, now this is problematic the way I have this written right now. The issue is this. What I mean to say here, what I intended to say here, is that I want to set the value of this guy equal to whatever value was passed in. That's what I want to happen. But that's not what has actually happened here. So we go back to that statement that all variables resolve to their most local definition. How many variable scopes exist right here? As you look at all that code there, if you were to draw a scope diagram, which I guess it's not really a thing, that's something I guess I invented, how many scopes would we have here?
I guess one.
One? Okay. Tell me about the one scope we have, and then tell me about the one you're missing.
Okay, there's like, okay, so the global scope is the public class, and the second one is player. It's not the global one.
Okay, so fair enough. All right, so we have, see, he was 0 indexing. So 1 scope, 0 and 1. All right, so kind of going back to, we said usually we can identify scopes by opening and closing curly braces. That's not a 100% rule, because like while loops, for example, don't come with their own scope. But as a general rule, we can be suspicious that anytime we see opening and closing curly braces, a scope might be involved. Okay? So we have, as he pointed out, our global scope here. So everything between this opening curly brace and this closing curly brace is part of the global scope for player. Okay? Then we have a more local scope that lives right here. Well, really lives here, because these 2 variables are part of that scope. Make sense? All right, now this scope lives entirely within this global scope. So this scope would have access to these variables defined in the more global scope. They're inside the same house. Okay, we'd have access to those guys. Now, like we said, what we intend by that line, even though it's poorly written right now, we intend to set this version of jersey number equal to, so this guy should be this guy, and this guy here, this guy should be this guy, and this guy here should be this guy. But now we have the issue that all variables resolve to their most local definition, or their most local scope. The most local definition of jersey number is right there. So every single time I say jersey number, I'm referring to the most local definition of it, which lives and dies right there. Which means I'm never actually setting this guy up here to a value. Make sense? Now, old school solution to this, in a language like C, when we didn't have a this keyword, let's assume that you don't have access to the this keyword here, and you might not have connected the dots yet anyways, but how could I fix this problem? What would be the quick fix to this problem? Yeah, make the names not match anymore, right? So maybe we come in here and we say, okay, well, this dude right here is now JN. He's our jersey number. So now we'll set jersey number, which its most local definition is not found here. It's instead found here. And we're going to set it equal to Jn, which its most local definition is found here. Now we've accomplished what we meant to accomplish, right? What's the problem with this? It works. From a legal programming perspective, this works. What would you say is a weakness of this? Why might this be a poor idea?
Might end up being a lot of variables to keep track of.
Okay, keep going with that. Why would that be a problem?
Just because over time with a huge program, you have tons of different variables.
Okay, so if you are looking at the documentation for player and you're saying, okay, well, how do I build a player? What does the constructor need from me? You know, when I'm building my house and the contractor comes up and he gives me a bill, I'm pretty sure he wants money, right? But in this case, the dude walks up to me and says, I need a JN. What's JN? Now, it's recent enough in our mind that we know it refers to jersey number, right? But we roll ahead 6 months, or as our program gets bigger and bigger and bigger, JN might start losing what it meant, right? Okay, or you know, you get even worse when you see a lot of simple programming examples. Just int a. Okay, how are you using that dude, right? So realistically, naming that guy jersey number is a good idea because it's descriptive. That variable tells us what it's expecting us to pass in. Make sense? Languages like ObjectiveC, if we're comparing this to some older languages, actually were kind of interesting, but they were much more verbose. So if I'm just I'll create a similar line to this. So if we were doing this in ObjectiveC, so kind of the Apple side that's been replaced by Swift, but first of all, in ObjectiveC, constructors did not need to be named the same as the class name. So usually it was something like init. So to write this equivalent constructor, we would say init with jersey number and rating. Something like that. So that would be the header for that guy. Then you'd have your opening and closing curly braces below that. So now we're able to use the JN and use the R as like little short variables that are easy to type. But we've described what they mean. JN is the jersey number, and R is the rating. That makes sense? It's almost like writing a sentence. And at first, you look at that and say, oh, that's kind of a lot of crap to write. And the irony related to that is that Swift, Apple's new language, which we've talked about, is kind of not really trying to upgrade this. It's getting the other people to come over to the dark side, right? Getting people to come over and write iOS and Mac software. But has gone almost the complete opposite. They're trying to make you type in less and less and less stuff to the point where, I mean, you almost just don't even type. Like, you don't need a keyboard for Swift, dude. I think I mentioned at some point that you can name your variables emojis. Any of you have any friends or do it yourself where you send all your messages as emojis? And you have to like translate? My wife only does that when she wants like McDonald's or something. She has like a little emoji that's supposed to be her, and then she has like a sandwich thing that's like she likes fish sandwiches there. So that's my translation ability. I can't imagine when an emoji for a variable name makes sense, to be honest, but I also don't understand Snapchat, so it's so yeah, I guess this could be a me issue than anything else. So in any case, typically good programming practice would be to name our variable something meaningful. So when we come back to it in 6 months, or when we have a really large project, as he pointed out, we kind of know what was meant by that guy instead of just random variable names that we then have to look through our logic and find out what the heck did that guy mean. Okay? So because of this, he pointed out that our quick fix would be to rename this variable and like, oh, okay, now it works. But variable isn't a great name. So what we need to do is we need to have a mechanism for talking about this dude and also talking about this dude. So now we have that rule, and we'll go ahead and write it on its own slide again because it's important. We probably have it somewhere else in there. But variables always resolve to their most local definition. Nailed it. All right, so variables always resolve to their most local definition. So that's that. Constantly comes back to us, and this, kind of the practice for this is when you're looking at code, don't glance at it and assume what you think it does. Actually go through the process of resolving variables in your head and thinking about, oh, what is this guy actually going to be equal to? Oh, he'll actually resolve to whatever this value is. So that guy is an integer. He'll be whatever integer was passed in here. And what am I going to do with that? I'm going to set it to this guy. So get used to that idea of really resolving, doing what the compiler does, the runtime does when it actually runs your program. And before long, that'll become second nature, and you'll be able to debug your code much more quickly because you'll start thinking like a compiler. You'll start thinking like the Java runtime environment, the JRE, which then gets weird because you're no longer able to function as a human. But you got to go to one extreme, and then you back off a little bit, right? For like golfers, if you have a bad slice, the golf coach teaches you how to hit hooks. You just hit hook after hook after hook after hook, and he says, okay, well, now you have a bad hook. so let's back that off a little bit, and you meet in the middle, and you hit a straight ball. So then you'll be able to feed yourself again. So you have that to look forward to. All right, so we need a mechanism for referring to this guy up here, effectively bypassing that all variables resolve to their most local definition. And we do that by saying this, and this is what you were referring to before. This dot jersey number, that's saying I'm going to take my field, name jersey number, and set it equal to whatever the most local definition of jersey number is. I'm going to take my field, named rating, and set it equal to whatever the most local definition of rating is. Make sense? All right. Now, I like to always use the this keyword when it's appropriate, even when it's not required. So when he gave us the example of, oh, can't we just change this variable name to JN? Here, wouldn't you agree that this dot is not required there? We don't need the this dot. It will find that variable. Why is this dot better? I want two explanations on why. Well, there's really three. The first one is because I said it is. Okay, the next two, because I want you to be individual programmers, are going to be a true argument as to why this guy's better. Why would it be preferable to write it this way? Effectively tell me why I'm right in saying you should write it this way. Don't give me the crap the teacher's always right. That's not true. Isn't it always funny when you're sitting in class? It seems to happen more often in math classes, I think. That was my experience. When the teacher's just going in the wrong direction with a problem, and you're sitting there like, well, what the heck is going on? And then sometime about 10 minutes later, like, oh, wait a minute. Does that ever happen to you? And then the teacher kind of like pretends like, oh, I was taking you down this path. Yeah, I do that all the time. All right, now you can answer the question. Reveal the secrets. What's good about saying this dot jersey number is equal to JN? Throwing out the idea that the JN is a bad variable name. What's good about saying this dot? Good.
Like, it helps you know that for sure it's using field variable, and also gets in the habit of using
Okay, so you're being very explicit about it. All right, so by us saying this dot jersey number, we're not beating around the bush here. We're saying, I mean this guy. Whether it would ultimately become that guy or not, we're that guy. Why is that better?
That's what you're trying to use.
Okay, that's the guy you're trying to use. Do you think that might be faster? So if we connect this to real life, let's say you're looking for your keys. Okay, and your keys are in one of 4 places. Typically, you'll probably look in the place that's most local first, right? Like you look in the living room under the couches and stuff like that. Then you go upstairs and you look up there. So you kind of spread out. You're walking from local scope to a little bit bigger to a little bit bigger until you finally find the keys, right? So they can be in 4 different places, let's say, or in this case, 2 different places. Or in his case, 1 different place, indexed at 0. Okay. So I can look in this room for jersey number. Or I can bypass that waste of time and just say, oh, I'm just going to run upstairs real quick because that's where I left my keys. Make sense? So by explicitly saying this dot jersey number, it's actually faster. We're bypassing a wasted search, searching in the local scope for this guy and just going immediately to the global scope for this object. So the follow-up to that is, do we care? Do we care that it's faster? From maybe from a trivia perspective, like, well, technically this is a little bit faster, but do you envision this being a problem that's a really time-consuming thing for a computer? In terms of number of instructions, for those of you who are in the 325 class, yeah, it's going to add a lot of instructions behind the scenes. Computers are pretty quick. We're not going to notice. A human being is not going to even come close to perceiving the difference in speed. But there is a difference, and it's, at least in a trivia perspective, important for us to understand how this is working in terms of resolving scope. All right, so it's faster, but we're certainly not hurting ourselves by doing this. Okay, why else? You said something about getting used to using it. Fine, so now you're getting used to using it for speed. Why else might it be good to get used to using it? We'll do a demo here. This dot. I won't misspell variables. It's convenient. It'll show me the guys that are up there. I won't misspell stuff, which then gives us maybe the freedom to use fuller variable names, more meaningful variable names, rather than play defense and say, well, I don't want to type that. I'm going to say JN just because I don't want to type my favorite 19 consonants or something, something like that. Make sense? So that's something that our IDEs provide for us. So it allows us to be a better programmer by not feeling like we need to kind of take shortcuts, cheat as programmers. So this dot faster. Now keep in mind, don't use this dot when you don't mean it. So if you, for instance, we wouldn't do this. Let's just do that. That wouldn't be right. I don't mean this dot here, right? I mean this guy, which is the most local definition of jersey number. So in this case, don't just randomly throw this dot in front of stuff thinking that, well, it's better, right? Kind of like when you're writing a paper, just add commas. That's my approach. So this isn't always right, but when it is right, when you do mean this guy up here, use this dot because A, under the hood it actually is faster. B, it allows you to write more expressive variable names because you don't have to worry about A, typing it right, and B, typing it at all. You just put the first letter of it, the first couple letters, and it'll give you in your list, and you press enter on it, and everybody's happy. Let's see, any other reasons? That's our 2, right? Yeah, good enough. So does that make reasonable sense? Now, having said that, we already showed that it's not wrong to not use this dot as long as you know, things are resolving to the right value. And you're not going to notice the speed difference. So if you know what you're doing and you don't like writing this dot, don't. I'm just suggesting that more often than not, it'll make your life easier. Typically what you'll find, especially when you look at historic programs that people write, typically programmers that have been programming for a long time that came from like C, who aren't teaching it. So I mean, my programming style has evolved over the years because I teach it. I need to show you shortcuts because you have enough problems to deal with as it is, right? So people who grew up writing C programs weren't used to a keyword like this. But similarly, they also kind of had this habit of trying to make things as short as possible. Part of that was because minimum memory and that kind of stuff. Part of it was programming was less accessible back then. So it's almost like job security. You write code that nobody can read, then you can't fire me. It's like, basically been self-encrypted all my code. The guy's sitting there with the Cracker Jack decoder ring thing. All those variable names are encoded. And there was a guy that did that. I think there's some story about it. All right. So that's this keyword. That's our constructor. Just to add a little bit more trivia in here for us. Other languages. C++ uses this. C# uses this. Java uses this. Visual Basic, anybody know what Visual Basic uses? Go ahead.
Actually, forgot.
Oh, now you have to answer. I've actually already said it today. Uses me. Okay, so refer to ourselves. All right. VB is actually the only one I know that does that. Let's see. ObjectiveC uses self. Python uses self. A bunch of other ones use self. Swift is self. Oh, I forgot one here. What does C use? Why? Why? Why didn't it have it?
Is it not object-oriented?
It's not an object-oriented language. Yeah, C was before object-oriented languages, so we didn't have an idea of objects. So we had nothing to refer to, right? So, trick question. Good job. All right. So that just gives you some trivia. When you are looking at code examples for algorithms, sometimes you'll find a C# or a C++ or a Swift example of something you're trying to do, and when you see the word self, that's an equivalent to this. You'll only see me with Visual Basic, so that's not a common thing, but typically in modern language you'll see this and you'll see self, and they mean the same thing. Okay, so there's our constructor. We take in this case, 2 parameters. We'll go ahead and set our field jersey number equal to the value that was passed in. And we'll set our field rating equal to the value that was passed in. Okay, so let's leave it at that for a second. Let's go back over here to driver. All right, did I paste this somewhere that we have it?
It might be.
Here, let me just throw it on Slack real quick, and because I'm about to delete it. I gotta make sure I never click on this tab in class because we say bad things about you, especially you. Oh, and definitely him. What class is this guy? Actually, the funny thing is we just have a lot of memes in there. This is what, chapter 6 homework? 7? We just read chapter 7, didn't we?
This was 6.
Yeah. Okay. There. So now you have that code. So I can delete it. All right. See, now the class is getting cocky. Usually you get the oohs and ahs, like, oh my gosh, you just deleted gold. Do you know how long that took? All right, so we're going to go ahead and this was our blueprint. So we talked about, we created our blueprint to give to the contractor who's going to build our house for us, right? So all we've done is we've built a list of instructions for what it means to build a player. We haven't actually built any players yet. Make sense? So now let's go and build a player. This is our class definition. Now we're going to utilize that class. Similarly to our methods, where we define the method, which is an untapped resource, and then we actually call the method from someplace else. Make sense? Two separate places. So we're going to go ahead, we're going to create a person, or a player, right? Player. So we'll say player P is equal to new player, and our player requires 2 parameters, a jersey number and a rating. So we'll say this guy is jersey number 15 and rating is 3. Okay. Did I throw a comma in there? Oh no, I print. Oh no, we're good. Oh, tell me what's wrong with my program right now. This would be one of those examples where like the math teacher screws up, but I can use it as a teaching. Why am I getting an error? Keep in mind, I just deleted a whole bunch of crap. I don't have a main. All programs begin and end with main, and I deleted mine. All right, so we'll cut this real quick. Public static void main string array args. All right, now we're back in business, right? All right, so I went ahead and I'm creating a variable named player. That's my type, or I'm sorry, a variable of type player named P, and he's going to be equal to, here's me using my constructor to build this guy. So the name of the constructor is player. It takes 2 parameters. I'm passing it 2 integers. Why? Because he expected 2 integers from me. And then he does whatever magic is required. Okay? And then I'm going to go ahead and print out that player. What's the output of this program going to be? It's not a trick question. You have all the everything you've learned in here. We didn't learn about this today. This is something you've learned about weeks ago. What's the output of this program going to be? 15 and 3? Okay. Why? Okay. So you just think magically this guy just will work that way?
Probably will print memory address.
Ah, print a memory address. Why will it print a memory address? New keyword. New keyword was involved here, right? What does the new keyword say to do? It says, go and get me some real estate. Go and get me some memory big enough to hold this guy. So in real life, what would we do? We would work with a real estate agent who would, we'd have to pay somebody probably for the plot of land. So when we hired the contractor, the constructor to build our house, we'd hand him the blueprint, we'd hand him a bunch of money and probably give him the address where we want him to build it. And he could pull the permits or whatever. He does all his magic. But we kind of want him to build the house in a specific place, not like throw it in just some field somewhere and just say, yeah, this is where I had room. Right? So the real estate agent's going to go and get us some memory. We're going to return that memory to P. So P is a pointer to the place in memory where this constructor actually builds our player object. So if I run this, we're going to see we get a weird looking player address-y looking thing. I did hit play, didn't I? Oh my, have I hidden my no? Let's kill Eclipse and reopen. I'm doing this correctly, trust me. Do I have to select this guy over here in order for it to run? It's not running any of this stuff. Default package. Let's do this, do this, do this. This is unfortunate. What if I run from up here? Does anybody see, am I doing something stupid? Because this code works. Driver, void management, args. Okay. That's strange. Okay. Well, let's, I guess we'll run this out at, just give me where this guy is. I guess it doesn't really matter. All right, so we'll compile it. We'll run it. It's a stranger. Public class driver. Public static void main string array args.
So you have to extend player and public class driver.
No, we're just using player in there. Oh, sorry. I should be compiling driver, not player. Player does not have a main method, and a driver does. Oop. All right, so there's our memory address. Is that big enough? I have no idea why Eclipse isn't working, so let's just screw with that later. All right, so there's our player memory address, but we really want it to print out something more than that, right? So what we can do is we can come out here and we can say, well, we want player dot jersey number. So I want to print out this player's jersey number, and that'll give me a 15 in this case. So I'll, just out of curiosity, let's just see if it magically works now. No. So I need to recompile because I changed it. Then I'll go and run it. There's my 15 for my jersey number. Okay. Now, the reading, let me get player opened back up here. Do this. We call this guy field method security. We have three options: public, private, protected. Did the reading talk about those? Huh? Just public and private? That's fine. So forget about protected for a second. So what's the difference between public and private? When would we use those guys?
Private is in the global scope mainly.
Okay, you typically would use private in the global scope. It doesn't have to be only there, but that. So effectively, I would recommend you always make these guys private. But now we want to give a reason for that, as opposed to, oh, because he said so. What does private mean?
You can't help the public like carry out their tasks or something.
Help the.
Like can't help the public class.
Yeah, I don't.
Uh,
I don't even know what you're saying.
help public methods carry out their tasks.
Help public methods carry out their tasks.
I think that was a private helper is what the book called a private helper.
Oh, okay. So if you had a method that was private, that means, well, I'll give away the definition here, but okay, we'll swing back. I think that's the answer to something else.
Okay.
So what's private?
You can't directly access them in the class. You have to use like one of the methods.
Okay. Kind of closer than that. Yeah, it was pretty far off. All right, so private. So usually I would call these private members. So members of a class are fields, methods, and constructors. Those are the members of our class. So if we throw that in a slide here, class members are made up of fields, constructors, and methods. So these are variables, these are constructors, these are methods. All right. So fields is kind of a synonym for variables owned by the object. So private members are members that are only accessible from within the class in which they were defined. Okay? Are members that are only accessible from within the class in which they were defined. So that means since both of these guys are defined as private, I only have access to them inside of the class named player, because that was the class in which those guys were defined. Make sense? which means that I don't have access to that guy inside of a class named driver. So by making that private inside of player, I've made this illegal code. I cannot directly access a private field of player from within driver. Does that make sense? Private means it's only accessible within the class in which it was defined. Defined inside of player as private, so we can use it anywhere we want inside of this opening and closing curly brace. That's where it's accessible. Public means it's accessible here, there, and everywhere. Right? Anybody who has scope access to a player would have access to the player's public members. Okay? So we'll say accessible anywhere. And protected, I'll just foreshadow this real quick. This is like private, but for inheritance. So protected says that our variables are accessible within the class in which they were defined, as well as descendants of that class, classes that inherit from that class. Okay? Not too important right now, just kind of completing because we're not talking about inheritance quite yet. All right. So now, because I've made these guys private, and I always recommend that. My recommendation is to make variables private initially, and then loosen the reins as you need to. Variables and methods. So make them private, which will then give you full, be completely restricted. And then if you happen to come across a situation where you do need to have access to it outside of this class, then you can loosen up that security a little bit to give it access where you need it. Maybe protected. Public would only be for usually methods. You typically would not want to make fields public. Why is that? I think it was probably part of the reading, didn't it? The reading talking about mutators and accessor methods.
They called it like the setter and getter.
Yeah, I call them setter. Yeah, setters and getters is the modern thing. Historically, it's mutators and accessors. So why would it be a bad idea to have fields public? Or why might it be a bad idea to have fields public? Go ahead.
Is it because if we try to use like the same variable name in a different class, this is gonna be.
Okay, so you're concerned possibly of like variables conflicting with each other? Yeah, I mean, reasonable concern. I don't think that would play into this, but I mean, that is something you do want to be concerned about. This might get into kind of what he was talking about if you have a large project and you have multiple objects that all have the same variable name, like maybe they all have a variable called count or something like that, where they wouldn't conflict with each other in reality, but you might use the wrong object's count variable thinking it was a different guy. So I guess that's a possibility. Why do you lock your car? Hopefully most of us lock our car when you're in Concordia's parking lot. I mean, Concordia's a pretty safe place, right? You wouldn't put it up. You would feel like you needed to lock your car more at like Walmart or Bayshore or something like that than at Concordia in the big scheme of things. But you still lock your car here on campus, right? Why? You don't want people taking your crap. Right? You don't want them coming in and stealing your cassette tapes or what do they have to say? You think? Does he really think they still have cassette tapes? What? Your car has cassette tapes,
Yeah.
or has a cassette player,
Cassette player.
but you don't use it
No.
Mine is a cassette player and I use it.
with cassettes, or for the cassette thing that allows you to play CDs. Remember at the beginning of class we were talking about how it's kind of moving towards hatred? Yep, we're there.
Oh, I like older things. I also bought a VHS player at Goodwill because VHS are 50 cents at Goodwill. So if it's movie I like 50 cents. Billy Madison got 40 use out of that. Did you ever see that movie?
I've seen Billy Madison, yeah.
That's kind of.
No, I usually don't watch movies that have swear words in them.
I feel like that's my personality.
Yeah, Billy Madison's funny. That was back when he still made pretty good movies.
Once he had kids, it went downhill.
Yeah.
Then he cleaned up his act.
I liked Happy Gilmore, probably that's
Yeah.
probably my favorite one.
Waterboy was good.
Yeah, Waterboy was good. Yeah, so at least nobody has an 8-track player though, right? Okay, so he's concerned someone might steal one of his cassettes to sell on eBay as an antique, or possibly as one of his VHS tapes that he forgot to rewind. You should go into like Family Video and go to return one of those. It's like, man, I'm so sorry. It'd be good, 50 cents for the joke, right? You just buy one for 50 cents. So you lock your car so people don't take your stuff, right? Well, why? You want to control access to your stuff. Now, if you had a friend and you left your laptop or your phone or something in the car, you might be inclined to give your friend your keys or something to run out and grab your phone or your laptop or a book or something like that from your car, right? Because you trust them. You're controlling the access to that vehicle, right? So we might want to have a level of oversight associated with our variables, associated with our vehicles. So we lock the doors, and then we decide who and when we want to give access to. Okay. Now, at the same time, we might want to do some oversight. So cars have like the little code on them. Some of yours probably doesn't. It has the cassette plays, but like my car. It's like a new car. It's from this decade. It has the code on the side of it, right? So I have a couple of friends who have the code, or the code to my garage in my house, which like way too many people have. Like a lot of students have the code to my, which is scary actually. When you give like hard exams or something, things could happen. Yeah. Yeah. Plus my code's pretty funny. I can't say it on tape, but. That goes all back to the whole, I don't watch movies with swear words in them. So, yeah, now you have a short list of 4-letter words. That could be my garage code. In any case, we want to control access to things, so we might provide access or we might create some level of oversight. Only people who know the code to my garage, who can provide that input, are allowed to access the stuff inside my garage, right? A real life pattern. So what we would do here is we would have private members, locked car, garage is closed, locked behind the code, and then we want to go ahead like a hair or something. Then we want to go ahead and have some way of providing controlled access to those guys. Now, the historic name for these guys are mutators and accessors. Did the book mention those two words? Yeah. So historic name is mutators and accessors. So mutators are methods that allow one to change the value of a private member, potentially with some protective logic. So as an example, if you're going to change the value of some number, maybe you don't want to allow them to change it to a negative value. So if they try to pass in the number -5, you'll say, well, if the value is greater than or equal to 0, let them change it. Otherwise, ignore it. So you're providing some oversight on how you let them change it, rather than them being able to just change the variable willy-nilly directly, right? Where you don't have any chance to say anything. Accessors provide external read-only access to a private member. Okay? So if we're going to lock down a variable so that we can control read and write access, And write access to that variable, the ability to change that variable, is going to have to go through some level of oversight, but we still want to provide people with the ability to read that value, to gain access to that value. That's when we create an accessor method. So a public accessor method can give us read-only access to the value contained within a private member. Make sense? These guys, the modern word for this is setter. This guy is typically referred to as a getter. So what we might do in here is we might say something like public get jersey number, and we will return this dot jersey number. And this guy's going to return an int. And then out here, instead of saying p dot jersey number, we would say p dot get jersey number. Call upon that getter method, the accessor method, which are just fancy names for it's a method that happens to do something related to providing access to a private member. Make some sense? All right, so let's look at the book for reading. Let's see, so you read through 7.8, right? So let's do 7.9, 7.10, 7.11, possibly for a quiz on Thursday, because we're not really ready for the next programming assignment. Sound good? 7.9, 7.10, 7.11, be ready for a quiz. All right, I will see everybody on Thursday. And also, oh, don't forget, Thursday after this class, we have the computer science get-together down the hall there. Make sure you show up early so you can do the meet and greet thing. That's where the best prizes come from. So get to meet your classmates and other CS people, but they have pizza and all that crap, so they'll feed you, but show up to that thing. It's popular. All right, I'll see everybody Thursday.